Welcome back to another video here at 45 Drives. My name is Brett Kelly and I'm the technical director here. Today we've got a very special video for you from a new video series that we created to aim to show our best practices for general purpose storage architecture. So why? Well, we wanted to take it back to the basics and to show you our best practices when using open source software. Best practices that we've learned from working with our customers over the last 15 years. So one of the best part of open source is that it's incredibly flexible and allowing you to bend things as you want it. But one of the downsides is how flexible it is. How are you going to bend it? This is what can make open source a project. But by following our best practices and working with people like us, 45 Drives, you can remove the project from this. So now I want to emphasize that the principles discussed in the best practice videos are pretty much universal. They apply any place where the security of your data and the security of access to that data is incredibly important. It also applies to the most sophisticated enterprise applications at a large scale, all the way down to a small business and even the home. The way you implement them may be slightly different, but the principles do not change. So today we're focusing on best practice architecture for backing up your data, focusing on single standalone servers, but it also applies to storage clustering, which we'll focus on in some future videos. So with that, let's get right into it. All right, so what are we doing today? What are we talking about? Well, like I said in the intro there, we're talking about just general purpose, best practice architecture for your storage and for backing up your important active data that your company uses. Not your scratch stuff or whatever. Key pieces of your information of your company or organization should be that you lose it, that you are screwed. What's the best way to do that? And what we're doing is we want to go back to the basics and show you how we like to do that with open source software. Remember, with open source software, one of the best parts of it is it's flexible. It allows you to build your solution as you want. The downside of that flexibility is, what way should I bend it to make it work for me? So for those who know, great, go have some fun. Hope maybe you can pick a piece out of this video. For those who know that they want it, but they don't quite know where to start, that's what this video is for. That's what we're going to talk about. We're going to go through kind of the evolution of you using maybe all your users on workstations, saving everything on individual hard drives, to using a centralized network storage, how to back up from all the perils of the bad things that can happen, because unfortunately, those things do happen. And how you can protect against it, and what your best steps to, well, just avoid all those issues. So with that out of the way, with that scene set, why don't we talk about a backup architecture and how that would apply to you. So think about this. You're an organization that's been growing. You're working with about 20, 25 terabytes of data, not a lot, but very important data. It could all fit onto one hard drive if you want. We've got 30 terabyte hard drives now, but it's important enough that you got to keep it safe, and there's reasons for putting it in a storage array and backing it up, moving places, and we're going to walk through each of those step by step. So like that, we're going to evolve you from a couple workstations to a centralized NAS and kind of lay out our best tips on how you should do that. Okay, so with that scene set there of what we're working with, a small growing into organization, 20 to 25 terabyte kind of data set we're working with here. That's represented in this diagram here. So let me take you through the pieces, right? So first we've got our workstations, right? Like back when you start, maybe it's just you at one point, and you just save your data on your server, you grow out, now there's more people, and you go peer-to-peer sharing, you back things up that way, you recover, you lost something, whatever. That's what everyone does. You get your network switching and everything like that. But you're growing, we've already talked about it, and we want to store our very important data that you cannot lose. And that's the important part about all this stuff. What is the value of your data? You can't even quantify it because it's the lifeblood of the company, and that depends so much more. Anyway, data in this day and age is the most valuable resource, so you got to keep that safe. So you'd move to a centralized NAS, and what you do is you'd really have kind of an active pool of disks that are serving your data, and then on Deletion, yeah, you even have kind of like a backup of that data set, maybe even on the same server, maybe somewhere else. But we're going to talk about that deeper as we talk about kind of the perils of data storage. So bear with me, we'll get there. The other part of this is the scary part, the outside world. Modern society we live in now, you have to be connected to the internet. Your network really has to reach out, unless you're a government entity in some other tinfoil hat conspiracy where that, for a good reason, most people will have all of their network connected to the internet. So what we're representing here is your general firewall and all your cybersecurity networking tools that you would have in place to keep the bad people outside. But on the other outside of that network, we've got, well, the internet, great, but then other locations where you might want to put your data sometime. And we'll talk more about that, but that includes the cloud, we all know the cloud, or an offsite location, which maybe is another storinator where you keep your data, but we'll talk about that. So that's a quick look at what we're gonna go through as we go piece by piece of our storage architecture, our backup architecture. But as I break down what RAID we should use and how we can back things up and the technologies allow that to happen and the choices you want to make, we're going to do it by talking through the perils of data storage, the things that can go wrong and how your choices can protect you against each one of these things so you can sit there and feel at peace that you've got something that'll keep, like I said, the most important, valuable thing your company has, your data, safe. So the perils as we see it of data storage, the things to be afraid of, as Doug said at one point, the Grim Reaper with the scythe standing there next to your data, the things to keep him at bay. So the things that can go wrong, right? Hardware failure, things break. Data corruption, the software storing it destroys it, you can't retrieve it that way even though the hardware is still good. Data deletion, bad actor, accidental, someone goes in there and destroys stuff that you need. Viruses, ransomware. Everyone hates ransomware, lock that up and you can't get it, or another type of virus or anything, but mainly just ransomware, because again, stopping from your data, the most important thing in the world, is the scariest thing. Having an exposed root, what does that mean? Your root password and your house keys are just out in the world and anyone can come and go, and it doesn't matter what kind of mitigation you do. If you just leave your front door of your house open, not gonna work out. And then the big one, our favorite, the metaphorical meteor that everyone's happens. What is your plan for a meteor strike? Which I always think is the funniest thing in the world, because if a meteor strikes, I got bigger worries than that. But let's say it's a small meteor that locally just destroys your storage server. No, the point of this, that's why I said the metaphorical meteor, is anything that catastrophically destroys your physical data, your server, a flood, a fire, a meteor. My point is, no matter what you do up here to keep people out and keep people safe, the environment comes and destroys your stuff. How do you protect against that? All right, so the first peril that we were gonna talk about here, hardware failure. Remember, we're moving from just like storing locally to a centralized storage server. So that means taking a bunch of disks, putting them in one storage server, and building a RAID out of them, a redundant array of inexpensive disks. Why we're doing that? Because they all work together, share parity around or replica across from each other, and should one of those disks fail, the other ones can rebuild from it. Again, there's other ways your hardware can fail in your server, your power supply, your motherboard, the HBA card connecting everything. But upon replacing that, everything comes back and it's fine. If your hard drives fail, your data's gone. So you need to protect against that. So RAID, I just introduced it. So what is the best way that we see right now to do RAID? Like we said, there's a million different ways to do things. We feel that software-defined RAID, software-defined storage, is the best way to do this. Now again, you can do big things with Ceph and blah, 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 but we're talking about ZFS here. And we feel that ZFS is the best, most modern way to protect your data by building RAIDs out of your disks. Where are my disks? Right here. On your Linux server. Okay, and without getting too far into the weeds, because we could very quickly, talking about ZFS, because there's a lot to talk about, really impressive technology there. And actually, we do have a lot of videos on that, so I would recommend you checking them out if you want to learn more. But why we feel ZFS is the best is it runs on Linux, open, flexible, easy to get, widely portable, but mainly because of its copy on write file system. Again, check out a video we have on copy on write if you don't know what that is. But copy on write allows you to do things like snapshotting. It allows you to have crash consistent power loss and stuff like that. In the case that you lose power during your server or any sketchy thing happens during a write, you don't A, lose that data, or even worse, jump to the second peril, corrupt that file system and you lose everything. ZFS does this wonderfully. It's not the only thing that does it, but we feel it's the best one that does it. All right, let's actually make some real hands-on choices here. We've got a storage server here. Let's say this is an AV15, or a 15-bay storage server of the 45 drives enterprise line. And it's got 15 bays in it. So 20 to 25 terabytes, right? We don't need to fill the whole thing right now. So let's start with 4 drives. 4 drives of 18 terabytes. That's a great drive. Seagate Exos drives, enterprise level drives. We love them. We've been working with Seagate for a long time. So 4 of those drives. That'll give me raw 72 terabytes. The key word there is raw, because when I put these drives into a RAID, I'm going to lose some of that usable space because I need to keep it to keep the data safe should that something fails. So traditionally, you'd look at something called a RAID 5 or a RAID 6. RAID 5 means you can lose 1 drive and recover the whole array, or RAID 6, you can lose 2 drives and recover the whole array. You could also do something like a mirror or whatever, but for the sake of this video, we're considering parity RAID. That's what I mean when I say 5 or a 6. In ZFS terms, I like it because ZFS actually calls it a little more what it is. It's a RAID Z1 or a RAID Z2, meaning 1 parity or 2 parity. Or decoding even further, RAID Z1 means you can lose 1 drive, RAID Z2 means you can lose 2 drives. In the situation that we want to build here, that I want to start with 4 drives, RAID Z1's perfect for me. So I'll take my 4 drives of 18 terabytes, 72 terabytes raw. I'll lose 1 of those. It has to keep the space open for parity. So it'll give me a usable space of 54 terabytes. Now, that's damn near double, a little more than what we actually needed, but a little extra space is great because you're growing, right? Who knows what kind of exponential growth you'll see. We're in the age of data. Data is getting bigger and bigger and bigger. So what does that mean? We build a RAID Z1 out of your active data set. You could lose one of those drives there, pull it out, pop a new one in, and everything works. How would you set this up? Well, you'd use Houston. Houston is our web-based administration tool that easily shows you physically where the disks are in the system, and so that you can quickly fix things and see the state of everything without having to dive in the command line. So our active RAID volume, our Z pool, as it would be called in ZFS terms, consisting of 1 VDEV of a RAID Z1 array. Cool, all our active data is there. On top of that, I then make something called a ZFS data set. What is a ZFS data set? It's a fancy directory. All you need to know from a user point of view is that ZFS data sets are a 1-to-1 ratio between a SMB or NFS share. Point is, this is how your users actually access all this data. Think of a Windows share. Think of, you probably see on a network drive, a Z drive or something like that. That's how everyone will use it. You can have multiple of these data sets to shares on your active storage pool, and you can start using your data and everything's great. Another thing that could protect against hardware failures is multiple levels of backup, but we'll talk about that a little later in the video. So to recap, we can solve our hardware failure peril by using a RAID array of disks with Linux file server and a ZFS file system to give you a copy on write, safe, crash consistent file system that you can share out to your users. So boom, 1 peril down. All right, so peril number 2 that you want to consider is general data corruption. So, and I don't mean hardware failure like losing your data. I mean whatever's handling all your RAID and everything, it corrupting your data, or just general things like bit rot and stuff. So you want to pick a solution that is robust enough to handle general data corruption. So again, we introduced it with one, ZFS. It's great at it because copy on write, it's crash consistent, right? That and its intent log, the way that it journals its writes in, should something happen like an unexpected power loss, it's able to either like replay and recover what was written to it, or just like toss it off to the side. ZFS is known to write more like a database than a streaming file system. What I mean by that is it commits it or it doesn't. So, worst case scenario, if something bad happens, you might lose a little bit of that last write, but your entire file system cannot be corrupted. That can happen with other file systems, and I've seen it happen with other file systems. So we feel that ZFS is really good at handling that. The other thing that can come up with just general data corruption is bit rot. I got a great analogy for bit rot, but I'll spare you that right now because I got a lot to go through. So why don't you check out another video we did on what the hell bit rot actually is. But ZFS is able to combat bit rot by using checksums of its data to guarantee. Pretty much what they do is they go by and be like, all right, this file, you should be this number. What's your number? 6. That's not right. And then it can fix itself based on the parity. So right there, it's not necessarily hardware failure that it just recovered from. It just recovered by a bit rot, a bit flip, something changed. Anyway, check out that analogy video. It's one of my favorites. So data corruption. You got to pick a robust file system really that can handle data corruption. And we feel ZFS is the best choice here. All right, now the third peril you're going to want to consider is data deletion. So what do I mean by data deletion? Well, you've got your harmless, everyone's experienced accidental data deletion. Someone deletes a file they shouldn't have, they meant to do another one. Oh, you changed something with you realizing that you changed it, then you saved it. Even worse, maybe you did it a couple days ago and you don't even remember which version is the right version. You're panicking because you have to submit a report, but you don't think the report's right. Oh, what do we do? Anyway, there is a way you can deal with that. Or, before I get to that, what's the second scary part of data deletion? Malicious actors. Maybe someone got in, is deleting your data, or maybe you have a rogue employee who's just gone in, Control A, deleted it all because they're mad at you about something. Who knows? But how do you protect against that? Because regardless if it's column A or column B, data's gone, you want it back. Well, you could restore from a backup, which kind of references what we have a little bit, but I got a quicker solution for you. Modern file systems, like our favorite here, ZFS, have a feature called copy on write, like I mentioned. Copy on write allows you to reference, if you will, point in time snapshots of the data. And I'll write the word snapshot on top of here. Sorry, I'll scribble the word snapshot on top of here. And what a snapshot is exactly like it sounds. It's one of those few things in the IT technology world that exactly is like it sounds. It is a snapshot of your data at a certain point in time. So for that person who's trying to get their report back that they've deleted something and they're afraid they're going to lose their job or something like that, they can either themselves or call their IT team and go, I need the version of the file from 2 days ago. And they go, okay. And then you go and retrieve it from that snapshot and you bring it back. You can snapshot at the frequency of 5 minutes up to daily and every combination in between. Snapshots are awesome because they protect against that deletion, that accidental deletion or that malicious deletion. Because you can just quickly, and when I say quickly, I mean you just rip that stuff right back out of the snapshot. You can either restore it alongside or you can have it overwrite the original one that its future version replaced. Okay, so awesome. Now snapshots that protect against data deletion, amongst other things, but we'll get there, is not a feature unique to ZFS. A lot of different file systems support snapshots, a common requirement for most modern IT technology now. But we do feel that ZFS does it pretty much the best of everyone. Why? Because they're very lightweight on the file system. What do I mean by lightweight? It takes an instant to create a snapshot. You don't have to wait or anything like that. And they're very efficient on storing the differences. It doesn't take that much extra space. If I have my data set and I take a snapshot of it and I change 3 megabytes of that data set, maybe the data set's 25 terabytes like we were talking about, but we only changed like a sub 0.001% change of it, that's all that gets recorded in the next snapshot. It only tracks the changes. Copy on write. It's really, really cool. So, like I said, it's not unique to ZFS, but we do feel that ZFS does it the best, particularly in Linux. All right, so the third peril, data deletion, whether accidental or malicious, not an issue, because ZFS and snapshots keep us protected. So our little bad actor here, friend, who wants to come in and delete all our data through our workstations, see ya, bud. We don't have you anymore. Okay, so our next peril, viruses. Or, to be a little more precise, ransomware. That's what everyone's worried about here, because remember, we're talking about the protection of your data and the exfiltration of your data. Should someone lock it down that you can't get it anymore, or if they, even worse, they send it off somewhere else and they do something with it that they shouldn't. It's terrifying and it's everywhere. Go look, there's more ransomware out there than there ever has been before, and more political entities and nations are starting to ban the ability to pay off the people who lock your data. So that leaves you between a rock and a really hard place. So you got to try to protect against it, because if you're running a storage server, or if you have any data that's important to you, which is everyone now, then ransomware and viruses are an issue. So, well, you could make the case right now, well, I've got good cybersecurity tools, I've got everyone on the outside away, I've got proper access control lists, I've got my root hardened, no one knows my password, everything's ready to go. I'm not afraid of that. Well, you still should be, and I'm not sitting here selling fear, because it still happens. We've got all these tools and everything, but it still happens. Why does it still happen? Because of humans. Unfortunately, humans will always screw things up. And what I mean by that is kind of two ways. Everyone knows the story about clicking a link you shouldn't. The virus comes in, gets disguised in an email, comes in through here, blah, 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 it's sitting in so-and-so's workstation, click the email, start slowly encrypting everything on your network file drives and everything like that. That has happened. It has happened to us here, and it's happened to other people. It's a real threat. The other kind of part of that is you could then go, fine, we'll lock every door and blah, 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 and close all look. But humans still need to have always access to their storage, because that's how we work. We still need to fundamentally do stuff. Our job isn't to just unlock doors all day so we can get something done. So there needs to be a balance, right? Anyway, so this whole preamble out of the way is it's important to protect against your viruses. So in ransomware, how do you do it? Well, always have your cybersecurity layer. Great tool we have, Darktrace, love it. All kinds of people have different things and network firewalls and you name the tools. There's tons of them. There's a lot of good cybersecurity companies out there. But what can you do on your storage server to keep you protected? Well, you can use snapshots. Snapshots are a great case for this. If someone ransomwares you, try rolling back your snapshot. Maybe you didn't catch it in time and your snapshots all got corrupt. So even your most recent to your oldest snapshot has all been corrupted. Or even worse, maybe the latest snapshot's like three days ago or maybe a week ago and you've lost all that data in between. Okay, well combine that with your backups. Maybe it's on here, but it didn't send the backup and you've got a backup and you can retrieve that. Well, that takes some time too. Whatever. So snapshots is a great way to start. Cybersecurity tools, even better. This is the right way to start. This is a better way, a nice layer two. Backups even further. Another backups all over the place. But there is another option. It's a tool called SnapShield. And this is a product, a software product that we have built here at 45 Drives. And what SnapShield does is it's a tool that runs on the file server, local itself. Think of it as the last line of defense that sits on your storinator and watches for anomalous behavior. Because ransomware hits like a tidal wave. All of a sudden there's a lot of writes, a lot of entropy changes, and oh my God, what just happened here? So if you've got a piece of software like SnapShield, it can sense that someone has been compromised, it's attacking data on here, and it can boop, pop the fuse. And what that does is kicks that person off the network and allows the attack from stopping, and then gives the IT administrator that running the storage server, whether it's you or someone that you hired, the ability to see which files were attacked, revert them, and just those files, so you don't have to deal with this, oh geez, where am I restoring from? SnapShield, great way to protect against the virus. Because those humans will let them in, they're inevitable. But with SnapShield, proper cybersecurity tools, snapshots, backups, you can say, see ya to the virus. Okay, so the next peril, have an exposed root. So you're looking at me, what do you mean by that? That might seem like an easy one. I mean, having your root user, the admin of your server, the user account that can do everything, just kind of loosey-goosey. Maybe multiple users all use the same root user. Maybe your password's really simple. Maybe your password's like written on your whiteboard. I don't know. It has to be said here because for two reasons. It happens, and it's important to remind people, if you do not lock your front door, someone will walk in and dismantle everything you did. And that analogy is exactly all this. We could build everything against all these factors, but then let them in the front door, you lose. Turn it all off, it's broken. So always remember, don't want to have an exposed root, keep that locked down. What does that mean? Hard passwords, change the password, limit users who don't need access to the root accounts from using the root accounts. You want to harden your root, not expose it. Okay, before we get into the big one at the end here, the metaphorical kaboom, let's just kind of recap the more common things that can go wrong. And just like your hardware failure, corruption, data deletion, viruses, and then having your front door wide open. Two parts of this that we didn't really talk about yet, or two parts, but we're only going to talk about one of them right now. Having different Z pools, storage arrays, both inside the same box and somewhere else. Why do this? Because honestly, without these, we've still nailed our perils. But there was one word I said at the beginning of this video of like getting you back to work quickly. Should you have hardware failure and you have to restore, or maybe there's something seriously wrong, that this active is gone. It's gone. Well, maybe we backed it off somewhere else or whatever like that, but wouldn't it be great if I had another pool in the same system that was using another feature I didn't mention yet of ZFS, the send and receive of it, a complete block level differential only, meaning it only sends the changes, so it's really fast and efficient, that keeps this always in sync with this. So should ever anything happen to this, we could just nix this whole array and point all the shares that I talked about earlier to go from the active backup. That's really quick. There could be numerous reasons why you want to do that. Maybe something went wrong, I don't know. Maybe you just need to switch. The point is that it's very easy to switch that quickly. All you'd have to do is update a path in your file share. Oh, by the way, I mentioned it once before. How would I do that quickly? Houston, our web UI management tool, makes file sharing and pools all very easy. What about the backup task that keeps everything in sync? You can do that in Houston too. We can have automated tasks that keeps everything, boom, lockstep. Everything here is now down here as well. Okay, let's take that one step further. Let's have a cold backup as well. Maybe you got attacked here in a virus, and before you really got it, everything from here got down to here, and now this is corrupt, and maybe it is, maybe it isn't, but maybe you're worried. Screw it, let's just go to the cold backup. Maybe the cold backup is in the same server. It could be, that would work, but probably not. Probably don't want to do that. Maybe you want to put it off in another server in that same network that you live in. Maybe it's another server in the same rack. Maybe it's in another room. But it itself has a backup there, such that if this whole thing goes, we can jump to the cold backup. The point is you can have nested backups. So it's a Russian nesting doll if you want. We can go as deep as you want. Inception, blah, 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 reference after reference. But I digress. Having more than one Z-pool active and in sync with each other before you have to do a major recovery from what I'm going to talk about when we get to the sixth peril is a great plus of keeping everything up. Like I said, things are safe, but you want to restore as quickly as possible. So active backup in the same box, cool idea if you can fit it in there. But again, we're talking about 20, 25 terabytes, it'll fit in the box. Cold backup, maybe that's in the same server. Maybe it's in another server on the same network. Who knows? Some high-speed, fast network there. I guess we're supposed to tell you our best practices, so your choice comes down to how much space you need. But we'd recommend having a quick in-sync backup very close by, either on the same exact bus or on a high-speed network, a server or two away. Okay, so that brings us to our final peril here. And meteors are the metaphorical meteor, of course. It could be a real meteor. Again, I contend that we'll have bigger problems if it's a real meteor. But my point is it's catastrophic damage to your server and the environment around it. Fire, a flood, a meteor that's perfectly sized to take your storage server out. The point is that any of these backups and local things that you put in place, they're gone. You see it all the time. This fires, floods, no one's really safe. So an offsite backup is key. And that brings us to our corner of the board here we haven't talked about yet. That meteor strike comes in, sits right here, and all these guys are broken now. Boom, 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 boom. Can't get there, right? So at this point, you're in big trouble. Your data's gone. You've lost access. So it might be slower to connect everything. Not necessarily, but at least your data's still safe. So what would we do here? Well, you'd back it up. You've got two different locations here. So let's talk about first our good friend, the cloud. What do I mean when I say the cloud? The cloud's probably the most generic overused term in this world, IT world lately. The cloud just means computers somewhere else. But in this case, what I mean is cloud storage. I mean Amazon S3, I mean Google Cloud, I mean Microsoft Azure, I mean Wasabi. It could be just about anything. Ugh, I get all excited about it. My point is, it's another place that you can trust that'll keep all your data safe. So in the same way that I said that you can back up all these pools to themselves using tooling in Houston to make it easy, we can do the same thing as all this is happening, that every once in a while it kicks a backup up, out, over, and into the cloud storage. So you have another location to save all your data. Or maybe you don't want to put it in the cloud. There's numerous reasons why you wouldn't want to do that. Maybe there are regulatory rules around what kind of data you're storing that says you can't put it in a public cloud. Maybe you just don't want to use the cloud because the economic costing of it might not fit for you. Who knows? So what's another option you have? Well, ideally you can get another storinator and put that off-site somewhere. Maybe that's in another building in the next neighborhood. Oh, well, that dies in the flood too. Maybe it's a state away, a province away, who knows? The point is it would still work similarly to the cloud, and you would sync data from here. That's the sound it makes when data goes through tubes, by the way. And that's the internet. It's a series of tubes, but I digress. That's a joke. So we send data up to our offsite location, and then the offsite location can pretty much look just like this. Maybe you have an exact mirror, so when you bring it all back eventually, boom, everything's there. So how do you protect against a meteor? Well, you do everything else here, and then you go put it somewhere else too. That's the best way to keep all your data safe. All right, so that brings us to the end of the show today. I hope you guys enjoyed this. Hope you've learned something and got something out of it. And we'd love to hear from you both in the comments and email, and you know all the ways we can stay connected these days. But just to recap, you want to design the architecture that works for you, using a centralized storage, using offsite, and solving the perils of storage. You need good RAID. You need to protect against hard drive failure. It's gonna happen. You need to keep it safe. You're going to want to use ZFS to do that, in our opinion, on top of Linux. It's awesome. You're going to want a modern file system that can keep you safe against data corruption. Not even modern file system, modern software-defined storage, whether that be ZFS or Ceph, which I haven't mentioned, which actually there'll probably be more videos about this, but with Ceph. Pretty much think ZFS, but on a bigger scale. Data corruption, something modern that keep yourself alive from bit rot and all that nasty stuff. Data deletion, it's got to have snapshots. Virus, gotta have snapshots, gotta have your cybersecurity, gotta have good working safe protocols, a zero trust policy, if you will, because humans will always let someone in the front door. Speaking of that, lock your front door as much as possible. Don't expose your root, rotate your password, be weary about who has access to it. And again, those pesky meteors, keep an offsite backup, keep it in the cloud, keep it somewhere else so that your data is always accessible. So, as always, please reach out to us in any way that you know how. Socials, info 45 drives, the comments below. All of this applies to 45 Home Lab, to Pro, to Enterprise, and we can't wait to hear from you. Hope you enjoyed the video. See you later.